Problem 10.44. A marketing manager decided to test the effectiveness of an introductory letter to a mail survey. He mailed out 150 surveys with the introductory letter and 150 with no introductory letter. The mail survey with the letter generated 40 responses and 22 were generated by the survey with no introductory letter. So even with the information at this stage, we're thinking it's a two population scenario. We've taken two samples, a sample with an introductory letter and a sample without an introductory letter, and we've got the responses generated in each. Notice that this makes us also think about proportions, because we've got 40 responses out of 150, 22 responses out of 150. So we're thinking two populations, two samples, and we're applying that to proportions. So let's now have a look at part A and see what we've got to work out specifically. At the 5% level of significance, can the marketing manager conclude that the response rate to the survey is higher when an introductory letter is used? So two populations, we're going to do a hypothesis test. It's a 5% hypothesis test, and the trick, once we know we're doing a hypothesis test, is to think about whether it's one tail or two tail. The way we decide that is to think about whether direction is important, and because we're interested to see whether the response rate is higher when an introductory letter is used, that key word of higher tells us that direction is important, and therefore it's a one-tail test. Now, this is a good time to decide what's going to be population 1 and what's going to be population 2. Remember, it doesn't matter if you've worked through your problem with them the other way around. As long as you're consistent, your ultimate conclusion will end up being the same. So I'm going to make population 1 without the introductory letter and population 2 with an introductory letter. Now, because we're trying to see if it's higher when we have the letter, we're trying to see whether proportion for population 2 is larger than the proportion for population 1. Now, of course, our research question, our hypothesis of change, is the alternative hypothesis. So in the alternative, we're trying to see if population proportion 2 is higher than population proportion 1. We're trying to decide if the proportion with a letter is higher than without a letter. If that's the alternative, well, then the null is just the complement, and we can write that down as pi1 greater or equal to pi2. So the alternative, pi1 less than pi2, the null pi1 greater than or equal to pi2. Remember, you can rewrite these as a difference, so the null just could be written instead as pi1 minus pi2 greater or equal to 0, and then the alternative would be pi1 minus pi2 less than 0. Alpha is 5%. Remember, that's always a key indicator that we're doing a hypothesis test. So it's a good time to draw up the decision diagram. Now, when we're looking at a test for proportions, we're using the normal distribution. So our decision diagram is a Z diagram. It's a one-tail test because direction was important. So we've got to think about where the reject region goes. Remember, we have a look at the alternative hypothesis. And because it's pi1 less than pi2 in the alternative, that tells us that the only way we'd reject the null is if we got a small result when we did pi1 minus pi2. So pi1 less than pi2 is equivalent to pi1 minus pi2 being less than 0. So that tells us that we're only going to go against the null when we get a test statistic that's low down in the lower tail reject region. So we draw on our one reject region in the lower tail. Remember, alpha represents the total size of the reject region, so that tail is 0.05 in size. We've got to find the critical value. Now, this is a Z distribution, so we use the inverse Z table, and We can't look up a lower tail in our inverse table for Z. So what we do is we do the equivalent upper tail of 5% and we would get a positive 1.64. We then can use the negative because remember the Z distribution is symmetrical. So getting a lower tail is no problem for a Z distribution. You just find the upper tail value and then take the negative of it. So negative 1.64 is the cutoff for our reject region. If we get a test statistic that's in that reject region, we can reject the null. So let's have a look now at the working, and remember we've got our decision diagram at the top just to remind us of where the cutoff is. Now when we do a two population test for proportions, we've got to have both the sample proportions P1 and P2, and remember here we have not been given those directly in the information. Instead we've just been given the response rate and the sample size, so we've got to combine that information to come up with our sample proportions. We also have to find an average proportion across the two samples. That's our P bar value. So if we start with P bar is just going to be x1 plus x2, the two response rates divided by the two sample sizes added together. So we had 22 responses when there was no introductory letter, and we had 40 responses when there was an introductory letter. Add those two together, divide by sample size 1 plus sample size 2, we come up with an average proportion of 0.207. Now we still need sample proportion 1 and sample proportion 2, so P1 and P2. We just use our data and turn it into a percentage. So for population 1, the sample we took, we got a sample proportion P1 of 22 over 150, which turns out to be 0.147. And for population 2, when we took a sample, we got a sample proportion P2 of 40 over 150, which as a decimal is 0.267. Once we've got our sample proportions and our average proportion P bar, we're ready to complete the test statistic. Now remember, it's still that same format that we've seen for all of the test statistics. We have our point estimate minus the population result divided by standard error. The formula has just been customized for this particular application. So we put in our values for P1 and P2. Remember, for pi1 minus pi2, we use the hypothesized values, and we always work through a hypothesis test on the basis that the null is true. If the null is true, pi1 minus pi2 is equal to 0. You then have to put in the standard error, and that was the reason we had to work out that P bar value, our average sample proportion. So we can put in our P bar. We've got our sample sizes N1 and N2. It's a good idea to work out the square root component first. Get that, write it down to 2 or 3 decimal places. You can then compute the final calculation, and we end up with a test statistic of negative 2.57. So that test statistic, if we compare it to our decision diagram that we see at the top, well, it's clearly in this lower tail reject region that we've created. So our decision is to reject the null, and of course we then write it in terms of the alternative. This is our chance to link it back to the scenario. And this is where, even if you had had the populations around the other way, you would have ended up with the same final conclusion. So we can say there is sufficient evidence to conclude that the response rate was higher when an introductory letter was used. That's what the alternative hypothesis tells us. The samples gave us evidence of that.